Hi, it's Miss Smith. This week we're going to do surface area and volume for pyramids, and we're going to focus on regular pyramids, which means that the base is regular. So we're going to focus on squares and equilateral triangles since we know how to find those. And also a cone. And again, those are similar in that they have one base, and prisms and cylinders have two. So in a cone, just some terminology from a couple weeks ago. So we have our radius, the height, and then the slant height is this one over here. I'm going to use L, but just sometimes they also use an S. I was looking at the IXLs and the explanations use an S. So either way, that is the slant height. And then you might have to use the Pythagorean theorem. Sometimes if they tell you the height and you need the slant height, you might have to do the Pythagorean theorem. I'll do some examples after we go through all the terminology and formulas. And on a pyramid, so when they draw it, they usually will draw it. It looks sort of like a rhombus, so you could draw like a rhombus, pick a point off of that, and then you just connect them is the quick way to do that. And again, we'll do regular based pyramids. The formula will change a little bit if it was like a rectangle or not a regular base. So for right now, we're going to focus on that. So then we would have the height gets drawn. So when they draw the height in, it looks like it's coming from the vertex sort of straight down. And then it looks like there's a little right angle there. Again, I wouldn't get too caught up in that. So the height is there. The slant height would be, so let's remember when we did our nets. So the net would look like a square with four triangles that are all going to be the same. So we would have the slant height is this guy right here. So if you were to draw, so here's our height, here's our slant height, and then this length here, I'm going to call this, I'm just going to call it X for now because, again, I think they're using slant height, but it's the side of the square. It would be half of that because it's going to drop that in half. So if they told you like this base was 4, you'd use that to 2. So I'm just going to call that half of X. And in this case, we're using X as the side of the base. And again, that is just something that depends on what they tell you, but that is where that's sort of coming from. So the formulas that we're going to use on this one. So again, if you are okay on this pyramid one, just finding the area and adding them up, that's absolutely fine. The general formula for the surface area is 1/2 the perimeter of the base times the slant height plus the area of the base. So again, P is the perimeter of the base. And these are the same as last week. So L, again, I'm going to use L for the slant height, but I do think sometimes people use S. I like S for the side of the square, but I don't want to mix those two things up. And then B is the area of the base, and that just depends on the shape for what that is. So if we're going to do surface area, then you would find the perimeter, slant height, and B. What that looks like if you were to do, and I'm going to make, actually, no, that's fine. So this would be for a pyramid. Actually, I want there to be like a little chart. So we're going to do surface area and we're going to do volume. So they're just all in one place, and we're going to do pyramid. If you find a formula sheet you'd like to share, by all means, send that along to me or Miss Hunt. I'd be happy to share that. I'm not going to do it, but if you would like to or you think it would be helpful, I'm sure some of your classmates would love that. So for a pyramid, again, that's going to be 1/2 the perimeter of the base times the slant height plus the area of the base. This part right here, the 1/2 the perimeter times the slant height, is the lateral area, which is the not including the base. So that is still the same too, just as like a recap. So lateral area pretty much is not including the base or bases, depending on your shape. So when we talk about a cone, we don't do perimeter, we do circumference. So the circumference is, I'm just going to make a little side note here. If the circumference is 2 pi r, but we want to do half of that, then half of this would just be pi r. So when we do the surface area of a cone, we want to do pi rl. That's the lateral area, plus the area of the base is going to be pi r squared. So the surface area for a cone is pi rl plus pi r squared. And then for the volume, it's the same general formula for both, which is 1/3, and then base times height. And again, the base is the area of the base. So very similar to the prism and the cylinder. And then this one also is 1/3 b times h, but you'll often see that as 1/3 pi r squared and then times h, because the area of a circle is pi r squared. So I'm just going to do an example of each one of those, and then I will also do like a quick on the IXL. So I'm going to put this, well, I would write this, well, maybe write it all down, whatever works for you. You should be using it to help you do the IXLs and the quizzes, so that is sort of up to you. So let's say that we have I'm going to go with a square base pyramid. And again, don't get too caught up in your drawings there. So there's my square base pyramid. It might just tell you that. So, and I'm going to tell you that this is 6 and the height is 10. So if I tell you that the base is a square and this side length is 6, and I tell you that the height is 10, so we're going to find the slant height. So again, what that looks like is if the height is 10, it's going to fall here. I always draw this separate. So we need to find the slant height, and I'm going to call that L. We know the height is 10, so it's going to go right here. And then we know that this is going to cut that in half, so it's really going to make this 3. So what we need to do is find our slant height, because we're going to find the surface area and the volume on this one. So we're going to do 3 squared plus 10 squared equals the slant height squared. So that's 9 plus 100, slant height squared. So 109. And then we're going to take the square root of that. And I'm just going to leave that the square root of 109 until I do the plugging into my calculator. So when I want to do the surface area, then I'm going to do the surface area is equal to 1/2 the perimeter of the base plus, so I'm going to write that formula. So the perimeter of the base I need, so that's going to be 4 times 6 because it's a square with a side of 6. So we're going to do 1/2. We're going to do 24 times, and this is the square root of 109. I'm going to type that into my calculator. And then the area of the base is going to be 6 times 6 because it's a square, and that's 36. So plus 36. So then that is, I'm just going to plug it in that way. And I know you can't see my calculator, but my calculator is not close by to me right now. So we're going to do 0.5 times 24. I'm just using the calculator that is on my Chromebook. The square root of 109. And so I got this part right here to be 125.28, but I'm just going to do plus 36 because we want the total surface area, and that is 161.283. And then you would round to whatever they tell you to round to. And yeah, that's good. And again, that's if they don't tell you the slant height. Sometimes they do, but if they don't, you know how to use the Pythagorean theorem. And again, just leave that as a square root till you get to the end. And then to find the volume, volume's always the easier one. That's going to be 1/3, and then the area of the base times the height. So the area of the base, we found that to be 36, and our height was 10. So we're going to do 1/3 times 36 times 10. So 36 divided by 3 is 12 times 10 is 120. In terms of units, so if I told you that this was like centimeters, I'm just going to say units cubed for volume, and then surface area is units squared. So that would be how you would do a pyramid. And then if you were to do a cone, my favorite. So if I had a cone that had, let's make the radius 4, and I tell you that the height is 8. So if you were going to find the surface area, again, we need to find that slant height. And so we're going to do 4 squared plus 8 squared equals the slant height squared. So that is 16 plus 64, so 80. And again, we're just going to leave that as a square root until we get to the end. So we're going to use the square root of 80 as our slant height. So to do the surface area, we're going to do pi r slant height plus pi r squared. So again, that pi RL is like the outside of the cone, and then we add the base to that. So we want to do pi, radius is 4, slant height is the square root of 80, plus pi, radius is 4, so 4 squared. So on this one, I'm actually going to just plug that into my calculator, and I am going to take a minute and get my calculator to show you what that looks like. Some of the IXLs do tell you to use 3.14, so make sure that you do that. There is a pi button on your calculator, so I wish they would just have you use the pi button, but it's okay. All right, so I'm going to type this in my calculator how I have it written down. So I'm going to do pi times 4 times the square root of 80. Make sure you arrow so that the cursor is not underneath that. And then we want to do plus, I mean, you could make that 16 pi if you wanted, or we could just do pi 4 squared. And that is 162.6625. 182. And again, those would be square units. And then to find the volume, we're going to do 1/3 pi r squared h. So we want to do 1/3 pi, the radius in this case was 4 squared, and our height was 8. And again, I'm going to plug that in my calculator just like that. So I'm going to do alpha y equals 1, not alpha, yeah, sorry, my bad. 1 divided by 3. Pi is second in the caret button. And then times 4 squared times 8. And that is 134.04128666. And that would be units cubed. And that's that. So if you have any questions, let me know. I will put up some videos on the IXLs that go along with this. And if you have any other requests or you want to see that, either check into office hours or let me know or let Ms. Hunt know, and we can try to help you out with that. Thanks so much and have a great day.